Hey guys, we're continuing our work on chapter 2, and today we're going to be looking at two-step equations. So basically when you're solving equations with more than one step, you're basically working through the order of operations backwards. You're undoing the order of operations. Now notice here I wrote that this is a guideline, it's not a rule. So you really need to know the different properties that you're using. But in general, this will kind of get you by if you forget what you need to do first. And so let's take a look at a couple examples. So here I have this two-step equation where I have the operation of addition and then I have multiplication. Now if I were doing order of operations, multiplication comes before addition. In order to solve it, I'm going to go in the reverse order of that. So I'm going to subtract 3 first. This, remember, is an inverse operation of addition. And then if I subtract 3 from this side, I have to also subtract 3 from that side. So I have 2x equals 12. Divide both sides by 2. So simplify. And you are left with 6. Now, here's one of the things that I absolutely love about algebra is the vast majority of the time you are able to check your own answers. You could always know if you are correct or not by taking the solution that you find and substituting it back into the original. So if I take that 6 and substitute it in for the x, what I'm looking for is, does this create a true statement? So 2 times 6 is 12. Everything else comes down. 12 plus 3 is 15. If these two values come out to be the same, then that means most likely you did it correctly. If they're different, then you made a mistake somewhere. It doesn't necessarily mean that the mistake is in here. You could have done the mistake in your check. You just need to go back and try to find it. Again, it could be on either side of that. So here's one for you to try. Go ahead and take a moment and try this. And hopefully for this you found that t is equal to 16. Alright, moving along. So solving with two terms in the numerator. I know we looked at this a little bit earlier, but just a refresher. Anytime you have more than one term in a numerator or a denominator, it is assumed that those are grouped together. In other words, you could put parentheses around them. The best way to approach this problem is to go ahead and put parentheses around that. And let's get rid of this by undoing dividing by 3. So this says the quantity of x minus 7 divided by 3. So to undo that, we multiply by 3. So here those simplify out, and I'm left with x minus 7 equals negative 36. This is why that undoing order of operations doesn't work perfectly every time. But if you do think of this as being grouped, when you do order of operations and there's grouping symbols, remember you work from the inside out. But when you're solving equations and there's grouping symbols, you're working from the outside in. So in that regard, you kind of are undoing order of operations. Let's go back and finish this problem. Add 7 to both sides, and you get negative 29. All right, so hopefully you have that. You should check this, but for the sake of time, I'm not going to do that. Let's continue on. All right, there's one for you to try. Go ahead and take a moment and try to do that one on your own. And hopefully when you're done, you find that x equals 26. All right, deductive reasoning. That is where you have proof of some reason why you're doing something. So, when you're doing these problems, you need to know your different properties. So, you're going to be doing this in geometry a lot. You kind of create this T-chart. And what happens is here on the left are all the steps that you're doing. Here on the right are the reasons you're able to do those steps. So this first one right here, I just write out the original problem. Now if I were going to solve this equation, now when you're doing this you have to write it out long ways, unfortunately. That way it makes sense when you're writing out the steps. But if I wanted to get rid of adding an 8, remember I'd have to use the inverse operation of addition, which is subtraction. So to undo that, I'm going to subtract 8. And if I subtract 8 from this side, I have to also subtract 8 from that side. So this is a property of equality. And it's the subtraction version. So really it's the property, subtraction property of equality. So I should have wrote that at the beginning, but oh well, you get the idea. We'll do that. Okay, and then here we go ahead and we simplify through subtraction. So 8 minus 8 is 0. I'm left with negative t equals negative 5. So what you'd write here is, the book goes into a little bit more detail on that. For me, you could just write simplify. That's good enough. And then from here, you have to realize that this negative actually means negative 1. And this is how we're able to get rid of negatives in front of values. And this is the multiplication property of negative 1. And then in order to get rid of that, I divide by that negative 1, because this is negative 1 times t. So I have negative 1t divided by negative 1 equals negative 5 divided by negative 1. And this is the division property of equality. And then from here I simplify, and I'm left with t equals 5, and I don't know what that is. So your reason for that, or your justification, would just be to simplify. All right, I know that seems like a lot of work, but in some ways it is important because it says why you are able to do what you're able to do. Again, this is similar to a geometric proof, and you do a lot of this when you get to high school geometry. So I kind of like you seeing it early on now. That way you're kind of used to the format by the time you get there. Here is one for you to try, so take a moment and pause and try that. Alright, so hopefully when you're done you get something that looks like that. So go ahead and check. And that's it for today. Very, very short lesson, so I will see you all in class.